Okay, so now we're going to look at vectors from a graphic standpoint, which may help solidify some of the concepts that we have with vectors. Okay, so we're going to add vector 1 and vector 2. So again, in all of these, we're just adding two vectors. And in this case, it's a little bit more difficult for me to find my angle. So typically, right, if I'm looking at this, let's count how many spots we have. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 8 units. So normally I would say, okay, this is 0 degrees. So 8 cosine of 0 would be my x value, and 8 sine of 0 would be my y value. Well, in this case, I can actually just count that I have 8 in the x direction. It's heading to the right, so it's a positive. So I have 8. I have nothing going in the y direction, and I can double check that by doing 8 sine of 0, and I still get 0. So there we go. So that is the x values or the x and y value for that first vector. Now this vector, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going in the upward direction. So my y is 10, and again, this is at 90 degrees, so I could do 10 sine 90, and that would get me this value, and of course 10 cosine 90 would get me 0. And I can see that there's nothing from the left to the right on this, so nothing in the x direction. When I add these together, I end up just adding x1 and x2. So that's going to be 8 plus 0, so that's 8. And then 0 plus 10 gives me 10. All right, now I've got to find my resultant vector. We can also call that v with double lines, which is our magnitude of our vector. So to do this, remember, we're going to take our x value squared plus our y value squared. So 8 squared plus 10 squared gives me square root of 64 plus 100. And so square root of 168 is going to give me 12.8 in value. And then my angle is going to be the inverse tangent, like we've always done, of our y over our x, so 10 over 8. Now, before I do this on my calculator, I do want to notice that my 8 is a positive number and my 10 is a positive number, so we are in quadrant 1. So when I get my tangent, I don't have to do anything to it. It is as it is. So that angle, when I go ahead and work it out, is going to be 51.34 degrees. Now let's go ahead and draw what this vector looks like. So I'm going to take this 8 and 10. So I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then my resultant vector should be something along this line. So there's my vector. And again, you can use R in this case. That would be what we would call Z from our last chapter. Okay, so this angle here is 51.34 degrees. Okay, so let's try one more. These are easy because they are purely X or purely Y. Let's look at this first one. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a value of 10 on my X and nothing on my Y. And then this one is 1, 2, 3, 4. So I have 4 on my Y, but nothing on my X. So now I'm going to take and sum up. My X is 10 plus 0, so that becomes 10. My Y is 0 plus 4, so that becomes 4. I take the square root of 10 squared plus 4 squared, so that would be the square root of 116. So that would be 10.8. And then to find my angle, I'm going to take the inverse tangent of my y over x. So 4 over 10. And again, Before I calculate this, I'm going to take a look and see this is positive, so I'm in quadrant 1. I don't have to do anything to my angle once I get it. So the inverse tangent of 10 over 8 is, 4 over 10 is 21.8 degrees. Now let's see what that looks like when we graph it. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, I do get a resultant right here, and this is going to be an angle of 21.8. So that makes sense. Okay, you always want to draw it to make sure what you are calculating is in the ballpark of what you should have.